conical surface. Firstly, this conical surface will slide over the cone of dog, and because of friction between these two surfaces and the speed of synchromesh unit will be equalized to the speed of output shaft gear. When the speeds are equalized, then we slide this collar over the dog teeth of the gear. Say in this condition, the collar is away. In this case, the collar is slided over the dog teeth of the gear. After when this collar is slided and we are having a positive output. So, this type of arrangement is having definite advantage over the earlier type of constant mesh type gearbox. In this case, the speed of the meshing dogs are equalized with the help of friction, and after then the dogs are engaged. So, in this case there is a very less chance of damaging the teeth of dog, and the running is quieter. So, this diagram shows the neutral position of a synchromesh gear. In this case, the power is coming from the clutch shaft. This is clutch gear, or it is also known as the third gear. Here under we are having lay shaft. When the engine is running, clutch is in neutral position, this lay shaft is running. With this running, all the gears are moving with the same RPM as that of lay shaft, and the corresponding gears on the output shaft are rotating. But see the condition of both the synchronizer. Both the synchronizer, first and reverse synchronizer and second and third synchronizer is not matched with any of gear. All the synchronized sleeves are located in the center of their hubs. All the output shaft gears freewheel on the output shaft. The output gears are rotating, but we are not getting any output because these output gears are free on the output shaft, and no power is transmitted to the output shaft. Now, see, this is the condition of first gear. When first gear is engaged, a linkage rod moves the shift fork so that the first gear synchronizer is engaged to the first output gear. See, in this case, first gear synchronizer engaged with the first gear. Now, power is transmitted to the first gear and first gear to this synchronizer unit, and through synchronizer to the output shaft. Here, input shaft gear turns the output counter gears. First gear is locked to the output shaft. In this way, we have locked first gear to the output shaft, and small gear on counter shaft drives larger gear on the output shaft. Here we see this first reduction, speed reduction takes place here when smaller gear is matched with the larger gear. Again, speed reduction takes place when smaller gear is again meshing with the larger gear. So, we are getting a gear ratio of 3:1, and this is the condition of second gear placed. In this case, the first synchronizer is slide away from first gear, and second synchronizer is engaged with the second gear. Now, power is flowing through second gear to the output shaft, and the gear ratio is 2:1. See, in this condition, first gear and second gear, the RPM is increased and torque is reduced, and this is the condition when the third gear is engaged. Third gear, or sometimes it is also called direct gear. In this case, this synchronizer is engaged with the clutch gear, and since it is engaged with the clutch gear, it will have the same RPM as that of the engine shaft, and the gear ratio will be known as 1:1. This is the condition of reverse gear. As I have already explained, when we want to reverse the direction, we put an idler gear. Say this is the idler gear. When the power synchronizer is engaged to this reverse gear, the power is coming to this gear, then idler gear to this reverse gear. Here we will be having reverse direction of rotation. In the overdrive, the high gear is an overdrive condition. In this case, the we will be having still smaller gear on the output shaft, and the gear ratio is reduced to 0.87 to 1, and it increases the overall efficiency. And with this, I have discussed with the 3 type of gearboxes, and there are other components of the transmission system which include in say this is the engine with attached with the transmission system gearbox, and the power is to be transmitted from this engine to axle to wheels. We are having other components like universal joints here, 2 universal joints, propeller shaft, and a differential to axles. This longer shaft which transmits the power from gearbox to rear wheels is known as a propeller shaft, and here we are having 2 universal joints. The purpose of universal joints is to transmit the power at an angle. So, we can with the use of this special purpose joint, we are having power transmitted to the engine to differential, though the axes are at different levels. See this axis of the differential and engine axis are at different level. And next component is the differential. I will just tell brief about the differential. When vehicle takes a turn around a corner, the outer wheel of the vehicle needs to travel larger distance than the inner wheel to take a smooth turn. So, differential provides different in speeds while taking turn, and when vehicle moves in a straight line, it gives the same RPM to both left side wheels and right side wheels. So, differential is a mechanism which provides variable torque to the inner and outer wheel when vehicle takes a turn, and same torque when vehicle moves in a straight line. And see, this is a picture of a universal joint coupled with the propeller shaft. The propeller shaft is coming from the gearbox. It is revolving, and this motion and torque is transmitted to the differential through this universal joint. See, this is the construction of a universal joint. In this case, there are 2 forks, 2 yokes which are having a spider having a cross type construction, and these are called trunnions, and this construction helps to transmit power at an angle. Now, I will summarize all the things discussed in this the presentation. What is it? Firstly, what is transmission system? It is a collection of components which is used to transmit torque, say power to from engine to the wheels. Why we require this transmission system? Because engine develops power in a narrow range of RPM and torque, but in actual conditions we need larger range of torque and RPM. So, we need a system which can provide us a variable range. So, that is done by with the help of a gearbox. So, gearbox is a mechanism, having a mechanism based on meshing of the different size of gears, which provides the variable torque and RPM. In addition to this, it must also provide means of putting a reverse gear, so that vehicle moves in a backward direction, and it should be easy to move shift gears, and its operation should be quieter. And this slides describe the fundamental of the how to get the larger torque with smaller RPM. When we mesh smaller gear with the larger gear, we get larger torque output and smaller RPM. But if the condition is reverse, as in the case of overdrive gear, the output gear is smaller and we get the larger RPM at the output shaft than the driven gear. And gear ratio is given by the number of gear teeth, driven gear teeth over the drive gear teeth. It is written as 2:1 like. And directly coming to the operation of sliding mesh gear, sliding mesh type gearbox. This is called sliding mesh because gears are slided to engage with the lay shaft gear. So, this type of mechanism having disadvantage that gears gets damaged while engaging and disengaging. Next is the constant mesh type gearbox. In this, all the gears are in constantly meshed with output shaft, but they are not driving the output shaft. The power to output shaft comes through these dog clutches. Again, it is having similar disadvantage, but to the lesser extent than sliding mesh type gearbox. And last is the synchro mesh type gearbox. It is having improvement over the constant mesh type of gearbox. In this case, we use the friction on the conical surfaces. These conical surfaces are engaged first, then this collar is slided over the dog teeth to engage with the gear. And so, by doing this, we are equalizing the speed of gear and synchronizer unit, so that there is a no damage to the teeth. And these are the variable positions, and these diagram shows the other components like universal joint, propeller shaft, differential, axle not shown completely, and here is the last is the propeller shaft, universal joint, actual photo. This is the construction of universal joint. Thank you very much.